Hi everyone, welcome back to B.sc Chemistry Study Room. If you are new to this room, please subscribe for more video updates. And if you have already subscribed, please click on the notification button for more video updates. Today in this video, we are going to learn on how to draw the Lewis dot structure for compound. So here we go. Lewis dot structure for compounds. So in order to obtain an excellent and correct structure of a compound, these are 5 rules that is always supposed to be remembering when drawing the Lewis dot structure. Number 1 says count the valence electrons of the compound. Count all the valence electron on the compound. Then number 2, determine the central atom. Number 3, draw single bonds to the central atom. 5. Put the remaining valence on the atoms as lone pairs. 5. Turn lone pairs to double or triple bonds to make the central atom octet. So now let's go for some examples and see how to draw the Lewis dot structure of a compound. So now let's try going for number 1 and draw the Lewis dot structure for H2O by following these rules. Number 1 says count the valence electrons of the compound. We are to count all the valence electron of this H2O. The atomic number of hydrogen or valence is 1 times 2, the subscript. Then the valence electrons for oxygen plus 6. Then 1 times 2 gives 2 plus 6. Which gives 8 valence electrons. These 8 valence electrons are the valence electrons for H2O. So now let's go for number 2 says determine the central atom. Now there are notes here. This note shows that hydrogen atom never be a central atom. Hydrogen never be a central atom. Number 2, in a compound, the least electronegativity atom is the central atom. Always the least negativity atom is the central atom. Now here let's put oxygen because hydrogen never be the central atom. Oxygen. Then step number 3 says draw single bond to the central atom. Then we are to draw single bonds to the central atom for the terminal atom hydrogen H. Now let's move to step number 4. Step number 4 says put the remaining valence electrons on atom as lone pairs. First, count the single bonds. Each carries 2 electrons. We have 2 single bonds here, 4 electrons. So now we are to subtract them from our overall electrons, 8 minus 4, which give us 4 electrons, 4 valence electrons. So now this means we are going to distribute these 4 valence electrons to the atom, as says from number 4. So now we cannot distribute it on hydrogen because hydrogen always need 2 electrons to be octet. We are to draw them on the oxygen. Dot, 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 dot. 4 electrons. So now oxygen is greatly happy for being octet. Now number 2. Number 2 is Ammonia Nh3. In order to have the correct Lewis dot structure for ammonia, let's go back for the rules again. Rules number 1 says count the valence electrons of the compound. We know nitrogen has 5 valence electrons plus hydrogen 1 times 3 as the subscript 3, which gives 5 plus 3, which gives 8 valence electrons. And rule number 2 says determine the central atom. So we know hydrogen never be the central atom but nitrogen. And step number 3 says draw single bond to the central atoms as the terminal atom 3 hydrogen 1, 2, 3. Then hydrogen, and hydrogen. So now step number 4 says put the remaining valence electrons on atoms as lone pairs. So now first we count the single bonds, 3 single bonds. So now each bond carries 2 electrons, 2 and this one 2. That means 8 minus 6. 8 minus 6 gives 2 valence electrons. So now we are to distribute 2 valence electrons on nitrogen, not hydrogen. 1, 2. So let's go for rule number 5. It says turn lone pairs to double or triple bonds to make the central atom octet. So now before turning this lone pair, let's see whether nitrogen is octet or not. Let's try to distribute the electrons of nitrogen on its shell energy level to see whether it is now octet or not. K shell carries 2 electrons and L shell carries 8 electrons, 2 for single bond, 2 again for single bond, and 2 again for these single bonds, and the last are lone pairs, 8 electrons. Now nitrogen is really happy, no need to turn lone pairs into triple or double bond. So now let's move for number 3. Number 3 is a compound Cl2O. So now step number 1, count the valence electrons of the compound. For chlorine, the valence electrons is 7. 7 times 2 as the subscript plus 6 as the valence electron of oxygen, which gives 14 plus 6, which is 20 valence electrons. So now step number 2. Step number 2 says determine the central atom. Here oxygen is the central atom. Oxygen. Step number 3 says draw single bond to the central atom as the terminal atom chlorine, single bond, chlorine and chlorine, 2 chlorines. So then now step number 4 says put the remaining valence electrons on atoms as lone pair. So now we are subtracting 4 electrons from 20. 20 minus 4, which give us 16 valence electrons. So now as says from rule number 4, put the remaining valence electrons on atoms as lone pairs. We are now distributing these 16 electrons on these atoms. First, let's start distributing it on chlorine. 1, 2, 3, 4, 5, 6. Then the other chlorine. 7, 8, 9, 10, 11, 12, 13, 14. Now 2 electrons remain from the 16. 15 and 16. So now we are checking whether oxygen is now octet as the central atom or not. Let's try to distribute the electrons of oxygen on its shell energy level. K and L shell. K shell carries 2 electrons, 1, 2, and L8, 2, 3, 4, 5, 6. It needs 2 electron oxygen. So let's count from the Lewis dot. 4, 5, 6, 7, 8. That means we are putting these 2 lone pairs here, 1 and 2. Oxygen is now octet and happy. Moving for number 4, SO3. Number 4, SO3. So to have the correct Lewis dot structure, we go back to the rule. Count the valence electrons of the compound. Now sulfur has 6 valence electrons. 6 plus into 6 times 3 as the subscript, which gives 24 valence electrons. So now rule number 2, determine the central atom. Sulfur here is our central atom. Then draw single bond to the central atom. The terminal atom oxygen, 1, 2, and 3. So now step number 4 says put the remaining valence electrons on atom as lone pairs. So now, sorry, oxygen here, oxygen, oxygen, and oxygen. So now first we count a single bond. 1, 2, 3, 4, 5, 6. So we are subtracting 6 from 24 minus 6, which give us 18 valence electrons. So then the next step says put the remaining valence electrons on atoms as lone pairs. Then we are distributing all these 18 electrons on these atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Finished. So now number 5 says turn lone pair to double or triple bonds to make the central atom octet. So now let's check whether sulfur is octet or not octet. Sulfur is an element having 16 atomic number. Let's distribute its electrons. 1, 2, another energy level. 3, 4, 5, 6, 7, 8, 9, 10, another energy level. 11, 12, 13, 14, 15, and 16. That means it needs 2 electrons for it to be octet. So now we need to turn lone pair to form a double bond in the structure. So here is how to turn the lone pair. So the structure now will look like now having a double bond here in the structure as this lone pair. So the remaining electrons are here. So now let's put the 2 electrons here in order to make it octet for the lone pair. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now sulfur is octet and happy.